Okay, everybody. So today we are starting section 9.7, which is called the zero product property, or solving quadratic equations. So this is where we start to put together some of these things that we've been talking about. You might have noticed we haven't been able to find, at least with algebra, we've been able to find them with Desmos, the x-intercepts of a quadratic function, and then we completely left that alone and we started factoring polynomials. So what do those two things have to do with each other? And that's where this zero product property comes in. This is going to be based on some really, really simple fundamental idea, and it's a really, really big thing that's going to connect these two things of factoring and quadratic equations. So this is, I'm not saying it's easy because it's based on a simple idea, but really, really big, important idea going on here. So our first thing is, of course, some review about parabolas and their properties. And so here we've got some information about a parabola. We've got the axis of symmetry at x equals 1. So we know that it is centered on that line. The vertex is at 1, -1. So of course it's on the axis of symmetry down at the point -1. Its y-intercept is 0, 0, which means because this is symmetric, it's 1 unit away from the axis of symmetry. We'll go 1 unit away in the other direction. And that gives us our two x-intercepts right there. So we've got our shape of our graph like that going on. Then they went ahead and gave us our actual equation for that parabola, and they want us to confirm that information. And so the a in this case, so the number in front of the x squared is 1. The number in front of the b, the number in front of the x, which is the b in this form, is -2. In this case, c is 0 because there is no c term. Since we have a +1 as our a value, we can see that that goes up on both ends of the graph, as we can see in the picture. It goes up forever on both ends. When we go ahead and confirm our axis of symmetry here, we've got a b value of -2, so it's -2, and a value of 1. So the opposite of -2 is +2. 2 times 1 is 2, and 2 divided by 2 is 1. And that matches with what they told us, which is good. To confirm our vertex, we'll go ahead and plug in the axis of symmetry as our x value in our equation and simplify it. So 1 squared is 1. 2 times 1 is 2, so -2. And that is -1. So our vertex is indeed at 1, -1. And then the y-intercept, if we forget that it just is this c value, we can always plug in 0 for the equation and see that, well, 0 squared is 0, 2 times 0 is 0, and our c value of 0 is our y-intercept, just like it was given to us in the problem. Now, we're going to talk about some of these things today. We're going to need these skills. So solving a linear equation, these are 1- and 2-step equations. We're looking for, remember, always going and doing the inverse operations that we see. So here we see we've got x plus 3. So the inverse operation of plus 3 is -3. I do want to see you subtracting 3 from both sides, showing me that that cancels out, leaving x alone on that side of the equation. And then 0 minus 3 is -3. Over here, the inverse operation to -5 is +5. So I will do that to both sides of the equation to keep that balanced. It would cancel out on that side, leaving just an x. And 0 plus 5 is 5. Over here, I've got now a 2-step equation. I'm still going to do my addition and subtraction step first. I always like to think of this as I'm going to handle the things that are furthest from the x first. So I see a plus 10. I'm going to subtract 10 from both sides of my equation to cancel that out, leaving the 2x. On this side of the equation, 0 minus 10 is -10. Well, now I've got 2x. Remember, that means 2 times x. Well, the inverse operation of multiplying is dividing, so I'm going to divide by 2 on both sides. That'll undo that operation. And -10 divided by 2 on this side is -5. Finally, over here, I've got 3x minus 9 equals 0. Well, I see that -9. The inverse operation is addition, so I'll add 9 to both sides to cancel that out. Rewrite my new equation every single time. Algebra is here to help us think through our problems and not do it in our heads. As the whole point of algebra existing is so we can write it down and see what's happening and see for ourselves what's going on. 3x and the inverse operation of multiplication is division, so I'll divide by 3 on both sides to cancel that out. 9 divided by 3 is 3. So, a few things here you're going to have noticed. Every single one of these equations was equal to 0. You are going to notice that today. There's a good reason for that, and we will come back to it in just a second after we talk about this last part, which is a review of multiplication by 0. And hopefully remember, multiplying by 0, no matter what you start with, multiplying by 0 is always 0. So, pick a different color here. So if I take 2 times 0, I get 0. If I take 0 times negative 3, I get 0. Now here I'm asking the question, well, what times negative 10 will make a 0? Well, I can always multiply by 0 and get 0. In fact, that's the only thing I can multiply by there. And then 4 times what equals 0? Well, 4 times 0 equals 0. So this leads us to this really big idea in math. This is something that is super, super, super important in algebra and even going all the way up as far as you want to go in math into calculus and beyond. The zero product property says that essentially when two things multiply to 0 or multiply to be 0, one or at least one, I'm going to go with the expression or the phrase one or both, because we're going to be only talking about two things today. One or both are 0. And so what that says here is if I take two things, and I don't know what they are, a times b, why did I write a d? A times b is equal to 0. Two things multiplied together equals 0. One of the two things has to be true. Either a is 0 or b is 0. And actually, it could also be possible that both of them are 0, which would be a rare case that we'd have both of those things being 0, but it certainly could be. So let's take a look at how this zero product property is going to help us out. So here we have two things multiplied together equals 0. X and x minus 2, x times x minus 2 equals 0. So according to the zero product property, either this first thing equals 0 or this second thing equals 0. Now this first one is already solved for us, which is great. X equals 0, that's good. This other one we do need to solve. So I see x minus 2. I'm going to say, okay, well, the opposite of minus 2 is plus 2. That will cancel that out, and I get x equals 2. So in this case, if this equation is true, x times x minus 2 equals 0, I know that either x is 0 or, if I could write what I actually meant to write, or x is 2. And so we have two possible solutions. We know that either x is 0 or x is 2. X can't be 0 and 2 at the same time, but it's one of those two for sure. And then we can keep going. If we have something like this, where both of these things are linear expressions, that's not a problem. The zero product property still applies. Either this one is 0 or this one is 0. And so I'll write that in. Either x plus 2 is 0 or x plus 5 is 0. That's the only way I can multiply those two things together and get 0 is if one of them or the other is 0. In this case, I'm going to have to solve both. Here I see plus 2, so I'm going to have to subtract 2 from both sides. Cancel that out, and I get x is equal to negative 2. On this side, I see plus 5, so I know I'm going to need to subtract 5 from both sides. Cancel that out, and I get x equals negative 5. And that's an or statement. Either x is negative 2 or x is negative 5. I get two possible solutions there. Finally, they took away the helpful hints here, as they will by the time we get to the quizzes. But it's the same thing. Look back at the one before. I've got two things multiplied together that equals 0. So I know that either x minus 1 is equal to 0 or x plus 3 is equal to 0. And that just leaves me with two equations to solve. Neither one all that difficult. X minus 1 equals 0. The inverse operation is adding 1. Cancel out that. I get x equals 1. On the other side, I see x plus 3, so I know I'm going to need to subtract 3. That will cancel out. X equals negative 3. That is an or statement. Either x equals 1 or x equals negative 3. Now, the last part of this is these should look pretty familiar here. Expressions like this should look extremely familiar as the factored form of polynomials. That's why we've been factoring, is we want to be able to get that factored expression. So let's take a look at the final examples here. Just as a reminder, factoring changes addition to multiplication. That's so we can use that zero product property. And so we're going to do an example with a GCF, with grouping, and with a trinomial. So here we're looking at two terms, x squared and 2x. Well, I don't see a common number in the 1 and the 2, but I do see an x in both, so I can factor out the x. And then x times what makes x squared? Well, that's x times x. X times what makes negative 2? Well, that's minus 2. And so now I have that expression, x times x minus 2 is equal to 0. And because of the zero product property, either x is equal to 0 or x minus 2 is equal to 0. The first one's already solved for me. The second one I need to solve by adding 2 to both sides of the equation. That'll cancel out, and x equals 2. So I have my options here, x equals 0 or x equals 2. Next one up, I'm going to factor by grouping here. I'm going to look at these first two terms. I'm going to say, okay, what's the common factor between those? Well, that's x. And that leaves me with an x plus 5. In the second one, I've got 2x and 10. Well, I see a common factor of 2 in there. And 2 times x is 2x, and 2 times 5 is 10. And I see my common binomial, x plus 5. And what's left? X plus 2. Zero product property says that either x plus 5 is equal to 0 or x plus 2 is equal to 0. And I can solve those two equations to figure out what my final answer is going to be. So here I'm going to have to subtract 5, get x equals negative 5. Here I'll need to subtract 2. Subtract 2, get x equals negative 2. And so either x equals negative 5 or x equals negative 2 are my possible solutions. Final one here, we've got a trinomial. Remember, our key to look for on these is always going to be what multiplies to that b term, what multiplies to that c term and adds to that b term. So it multiplies to negative 3 and adds to 2. And so those numbers are going to be positive 3 and negative 1. If you're still, you haven't found that trick yet, remember you can always split that up in the middle there. Write it out as x squared plus 3x minus 1x minus 3 and factor by grouping. If you found the shortcut, by all means use it. You can see that in here they're assuming that you figured that shortcut out already. But I can factor out my common factor of x and leave me with x plus 3. Here I'm going to say, okay, well that's a leading coefficient of negative 1, so I'm going to factor out a negative 1, leaving me with x plus 3. Because negative 1 times 3 is negative 3. And that's going to give me x plus 3 times x minus 1. So according to my zero product property, either x plus 3 is equal to 0 or x minus 1 is equal to 0. And I can solve those two equations. So I subtract 3 from both sides of that one, getting x equals negative 3. On the other side, I would want to add 1 to both sides, and I would get x equals 1. And that is an or statement. So one or the other is true. So there you can start to see, if you found that shortcut in here, that would save you a little bit of time. There's also a little bit of a shortcut in here on these easier ones that you might be noticing. If you find that, great, same as before. Make sure it works. Check it out a few times, and then don't tell someone. This is a lot better if they can find that on their own and actually earn that shortcut. Okay, one big problem altogether. We want to be able to graph this equation that you see up here all by ourselves without Desmos. So we're going to look at this thing. The big thing here, coordinates of the x-intercept are always going to be the equations x comma 0, something comma 0. And so we find the x-intercepts by setting the equation y equal to 0. And so we'll say, okay, I'm going to flip it around because I like the 0 on the other side. X squared plus 6x plus 8 is equal to 0. Now I'm going to factor that. I'm looking for two numbers that multiply to 8 and add to 6. I think 4 and 2 are going to do it. So I'll factor it. I'm going to split that middle term up. X squared plus 4x plus 2x plus 8 equals 0. I'm leaving that equals 0 over there. You know I'm not dealing with it. I'll factor by grouping. A common factor there is x. I did not leave nearly enough room here, but that's okay. X times x plus 4. Here I have a common factor of 2 times x plus 4, which means my final factored form is x plus 4 times x plus 2. It's still equal to 0. Now we get to use that zero product property. Either x plus 4 is equal to 0 or x plus 2 is equal to 0. Here I'm going to subtract 4 from both sides, giving me the equation x equals negative 4. So I have the coordinates negative 4 comma 0 as one of my options. And here I have the equation negative 2 or minus 2. It'll cancel out and I'll get x equals negative 2, leaving negative 2 as my other x-intercept. So what we did here was we plugged in 0 for y. That equation, that being equal to 0, let us use the zero product property and factoring to set up two separate equations to find the two different x-intercepts. You know, they're not 0 both at the same time, but this one could be 0 or this one could be 0. And they're both separately x-intercepts. So we're going to go ahead and graph those on our graph. Negative 4, 0, and 2, 0. Our y-intercept will always be the c coordinate. And so we don't really need to do any of this because we know that that c coordinate is the y-intercept. And in this case, it was 8. So 0, comma 8. But we could always verify that by plugging 0 into the equation, seeing that those two terms essentially just vanish. They turn to 0, and we just leave the 8 left over. So we've got our y-intercept. Put the first one in the wrong spot. I'm like, this isn't looking right. Right there. Sorry. There we go. Our axis of symmetry. We've got a couple of options here. One way, we have our formula, negative b over 2a. We could use that. Another option, now that we know how to find the two x-intercepts, if we can find those two x-intercepts, we can remind ourselves that the axis of symmetry has to go through the middle. And so we could split that right down the middle. We could see that that middle point is negative 3. That's going to be our axis of symmetry. So this gives us a nice way to kind of not have to figure out the axis of symmetry quite as much. And then we can plug that in. There's no shortcut here. We've got to plug it in to find the y-coordinate of the vertex. So negative 3 squared is 9. 6 times negative 3 is negative 18 plus 8. This is where I want a calculator. 9 minus 18 plus 8 is negative 1. So I have the coordinates negative 3, negative 1. I can plot that on my graph. While I'm at it, I also might want to get another point here. So I know this is 3 away from my axis. I'm going to go another 3 away from my axis. And now I can graph it, right? Like that. So all without having to touch a calculator, we can find the axis of symmetry. We can find the x-intercepts. We can find the vertex. We can find the y-intercepts. We know it goes up because the a term was positive. We've got everything we need to know about this quadratic equation to be able to graph it. So when you do the proficiency practice here, this stuff right here, make sure you're looking back. You know, these things right here, these questions right here are going to go right off of those same exact questions on here, these ones. This next set right here, going to exactly match with these questions here. You've even got GCF, grouping, and then a trinomial. You'll see there's a few more 2 of each, it looks like. And then we've got just some factor and solves. So you don't need to do any of the graphing on these. You just need to go through, factor them, use that zero product property, and you're going to find 2 solutions. And then down here, you've got one where you've got to go all the way through with the 2x in front, and then a few more practice problems. This first sheet right over here, this is your proficiency practice. Do that first. Then you can jump to the CFU. I'm not even going to put it up today. You need to do this first. And then you can jump onto the back and try some of the harder ones. But I need to see this sheet done first before you jump onto the CFU. Okay, I will see you tomorrow.